in truth, like most PCB designs, not the kind of more sophisticated ones that are super high speed and RF and all that stuff, but most just simple PCB designs out there, people don't do simulations, right? Like PCB designers have developed lots of shorthands that basically conservatively guarantee that the simulations would pass if you had run them, right? So things like the three widths rule, for example, and like good grounding strategies in your stack up and like things like that, right? Okay, so that is basically just taking what you would have learned from simulation and reducing it into geometric constraints, right? And that's great. That's where Quilter's at today. So if you go to Quilter and you tell it, hey, I have bypass caps and I have a differential pair and I have, all these different things and I have a high current net, that's effectively what it's going to do. Is it's going to reduce it into a bunch of geometric constraints that encode those conservatively. Level 2, in my opinion, is let's start using fast approximations, right? So let's start using like quasi-static approximations, and those kinds of solvers that can give us mutual inductance or capacitance or whatever else on these traces, and then use that result that works in a certain frequency range, but not at the super high frequency ranges. And then the third level would be full wave, right? Like actually do a full FEM or FTTD solver that leaves no approximations on the table, gets you the true ground truth. And that's really the golden signal you would want to train over time. And when we started Quilter, I made the mistake of thinking to start there first, right? So I trained as a physics undergrad, and I was like, okay, well, let's just go straight to the Maxwell equation solution and just use that. Obviously, it's way too slow to do this kind of iteration with. So that's why it's there, but we put it on the shelf for now, and we're going to work up through these levels instead.
Okay, great. Very nice. Good. I'm glad you chalked that out. That was actually very informative. So